Ladies and gentlemen, in my Physics 4A class, I hope everybody do well. It's Monday today, so I'm going to do a lecture about chapter 8, which in reality it is example. It's called Bankit Curve Road. And the question says find an expression between speed of the car, Bankit curve angle, and friction coefficient between car and road. Okay, let me tell you what is the Bankit curve road means. Here in this picture, guys, you see all the curves on the highway, they have to be tilted. So if car goes on straight line, then it wants to take this part of curve. For example, it wants to take the curve to the left. Your road cannot be flat. Engineers, designers, they have to make the road tilt on the part of curve. Why? Because if we don't make the part of curve with angle, so that is called banked curve road. If we don't make that part of curve banked, means is accumulation with the angle, then what is happening, this car, when it's taking the curve, it will fly out, it will slide out of the curve. So in this picture, which it is from your book and I copy pasted from your book, chapter 8, you see the NASCARs usually, guys, they go with 160, 180 miles per hour. Sometimes it's 200 miles per hour, maybe more. And they take the curve with 200 miles per hour, but the cars, those automobiles, they don't slide out of the curve. So they don't go out of the curve. Why? Because they make the road actually all which it is curve with tilt angle. It's not straight, it's not flat, it is tilt angle. Now, what is the reason that car, if it has, more speed than proper speed, question is, why does this car slides out? So let me tell you one important thing. Watch, guys. For example, this is a very important topic. If I say this is a person, okay, how many forces do we see at this time when a person or object stays actually on the ground? Let's say this is object, correct? I can say we have in reality two forces. One force is mg, which is always down, correct? One force is mg, force of weight. And the second force, of course, is what? Fn, or normal force. In this situation, of course, Fn is equal with mg. Why? Because there is no motion on y-axis. So there is no acceleration on y-axis. Therefore, of course, Fn becomes equal with mg. Now, question is this. What if I already explained this one in the class. If n becomes more than mg, what is my conclusion? If Fn, let's say this is, if Fn, say this is Fn, becomes more than mg, here object will fly up, correct? Let's say this. It will go up. If Fn becomes more than mg, actually your pushing upward force will be more than mg, so object will go higher, will go up. Okay? What if Fn becomes smaller than mg? In other words, mg becomes more than Fn. See? So let's say this is object, correct? Therefore, what I do have two forces. One force is mg as always, and one force is what? Fn. But mg is greater than Fn. Then what is happening? The person will be shorter and shorter and shorter. So the object actually will go inside the earth. Watch. The object will go where? Inside the earth. It will push more the surface, so it will go more inside surface or ground. So here we can get one conclusion actually. When we have a car, so let's say this is a curved road. Okay, and let's say my car is here. Goes this direction. So what is that? It's Vt. Car goes by tangent velocity actually. Okay, so if it has more speed, ladies and gentlemen, this car will slide out. So this is sliding out. The car will slip actually. Okay. Let me see. Now, why? Why this car slides out? Because of this, look. Imagine here is the curve and car goes. On the part of the curve, if your velocity becomes more than it has to be, your car slides out of the curve. So what is happening? It happens because of this section. Your car slides out. Why? Because Fn becomes more than mg, so your car goes up first. So we can assume your car actually it takes distance from the road, and because it has tangent velocity, because of centrifugal force which it forms by centripetal force, this car will slide out of the curve. So one more thing, one more explanation I can tell you here. What is happening because of this? Let's say, for example, if n becomes very big, when if n of course becomes very big, then what? Then mg. When fn becomes more than mg, pay attention. Here is the part of the curve, correct? Here's the center of curve. Here we have the radius, actually, for example. So when fn becomes more than mg, and the particle is like swinging, so the car has tangent velocity, then that tangent velocity makes centripetal force. As we know, centripetal force is toward the center, but for any action reaction there is reaction equal but opposite in direction. Therefore centrifugal force, which it's caused by centripetal force, will move the car where? Out of the curve. That's why if you see on the most of curves, usually you have here a sign that it says, for example, go with 40 miles per hour. They say, okay, go with 35 miles per hour, not more. If you go with 45, what will happen? Your car will slide after. Does make sense? When they say go by 40 miles per hour, that is the maximum speed that you can have on the curve. Make sense? That is the maximum speed that you can have on the curve. If you go with 45, your car will slide out. Especially when it is rainy day, when it is icy days, when it is uh, humidity on the road actually. When it is water on the part of the curve, be careful please, because your car, it's the best conditions to sliding out of your curve if you have a little bit more speed than you must have. So these are all about banked curve. Now, so if we want to prevent the car from sliding out, what do we have to do? Pay attention. We have to do this. Imagine, guys, that this is part of the curve, and here what I have, this is theta, and this section is the curve, correct? So if we want to prevent our car from sliding out, we make banked curve road. So what we do, that part of the curve, we make a tilt. Okay? So this picture, it's called banked curve road, with the same as the picture that I copy pasted from your book. So now I am going to add another page here. So what I am going to have, it is this actually. Watch, guys. So let's say here is the curve. Okay. Let me draw a triangle. Here is the theta. Okay. And my car is, for example, on this curve. So let's say this is the car. Okay. And car goes on this direction, which is this is by tangent velocity. And here is the curve. And as we know, this curve has center, and also we have what? The radius of curve. So this is the radius of curve. Now what we need to do. Watch guys, remember in circular motion, dynamic of circular motion, we have to do RTZ coordinate system. What is RTZ? What is RTZ? It's this. Your middle finger is R, your index finger is tangent, and your thumb finger is z-axis. What is radial axis? It's toward the center. What is tangent axis? It's tangent on the circle. What is z-axis? Is actually up and down. So remember, we have to apply sigma f on radial axis or on central axis equal mv squared over r. Sigma f on tangent axis is mat, which let's assume car goes by constant velocity, so it will be 0. And sigma f on z-axis is 0. Why? Because your car doesn't go up or down. Make sense? So there is no acceleration on z-axis. So we need to verify all forces. So I am going to verify my forces first. So what is this one, guys? It's mg, correct? Fn is, this is Fn, is perpendicular on the plane. And pay attention now here. We want to prevent car from what? Sliding out. Okay. What direction is sliding out? This is direction of sliding out. So that's in reality direction of motion. Pay attention, not direction of motion of the car on tangent axis. No, that's actually this side. When I say we want to prevent the car from sliding out is out of the curve. Here is the curve, correct? Sliding out, I'm sorry that sometimes it doesn't work well. So here is the curve. Sliding out, it's this direction, it's out of the curve. So we want to prevent the car from sliding out. So let's assume outside, outward, out of the curve is positive direction. Then let's choose out of the curve is positive direction, okay? So far makes sense? So what I need to do then I can say I do have also what, guys? If I want to prevent the car from sliding out, I have to have, I have to have friction force here. Fs, let's say. Why do I call it static friction? Because of course we don't want the car moves. We want to have static friction force. What is wrong with this? My goodness. I'm sorry, guys. So Fs. Okay. So we do have three forces. We do have three forces. Now let's see what we can do for the picture. Watch, guys. I'm going to choose actually my coordinate system as this. So this is x-axis, or same as c-axis or r-axis, radial axis, correct? In the same way, I do have also what? Z-axis, correct? And tangent is on tangent, it's on the circle. So fortunately, because tangent velocity is constant, then acceleration is zero, so we don't have forces on tangent axis. So what I am going to have, pay attention please, I am going to have this. Look guys, this is my radial axis. So this r is same as little r, okay? Then what I have z-axis. Now let's draw the forces, very important. On z-axis here I have mg, correct, this one. Then here I have Fn, correct. Then what I do have here Fs, static friction force, or little f is better. Okay, so how many forces do I have? Mg, Fs, Fn. What do I see? I see Mg is on z-axis, so it doesn't make any angle. So it has only one component, which is on y-axis or on z-axis. But Fn, compared to r and z, it makes the angle, and Fs also makes the angle compared to coordinate system rz. Now we have to figure out what is this angle. Watch guys, by using geometry, if this angle is theta, pay attention here, this angle also becomes what? Theta. If this angle is theta, this angle also, which it is between friction force and r-axis, it becomes what? So here becomes theta. So I can say very simple, this angle is theta, and also this angle is theta. Okay, let me show you what is going on. Watch guys. So as I said, what I have This is, for example, r-axis. This is z-axis. Okay. This one is Fn. Pay attention. Then what I have, this is Fs. Here I have Mg. Pay attention. Now, if you take a look on this picture, Fs is on inclined plane, correct? So theta is there. So here I can say, let me do by different color. Watch, guys. What is this angle? It's theta. If this is theta, this will be theta. Excuse me. Do you agree? Yeah. Why? Because in this triangle, I can say, for example, if this is 30 degree, and this is 90 degree, then this will be what? 60, correct? Okay. Then what is this? Total is 90. 90 minus 60 will be 30. So this angle, any angle is, this will be same as that too. Now, what I am going to have, we know Fn, this Fn is perpendicular on Fs. Here, Fn is perpendicular on this line. Now, total this angle is 90. Let's say this theta, for example, which is 30 degree, then if that is 30 degrees, watch it. If this is 30 degree, how much will be this? 60. Then how much will be this? 30. Correct? That's why if this is theta, this will be theta, then this will be also what? Theta. Makes sense? This is a very important section of this problem. But you have to know what's going on. Now, I will verify my forces, which I did at mg, friction force, and Fn. Then, guys, because I do have the angle, I will verify my components. Fn here, what I have, what is this one? Will be Fn cosine theta or sine theta. This is adjacent for theta. You eat the angle like crocodile. So, see, when you eat the angle, this is adjacent. Adjacent loves cosine. So it will be Fn cosine theta. And in the same way, this will be what? Fn sine theta. So far good. This is for Fn. Let me do for Fs by what color you want me to do? By black one. Okay. So here is theta. And remember, you eat the angle, correct? It is adjacent. Cosine loves adjacent. So this will be what? The black one will be Fn, sorry, Fs okay. Will be Fs cosine theta. Am I right? In the same way, this will be Fs sine theta. Am I right? So remember, these are perpendicular. I know in the picture it didn't show up very good. And these are perpendicular too. Okay. Therefore, what I am going to have, pay attention. This is the most important section. I am going to apply these three things. Okay, how many forces do I have on radial axis? Oh, I see this. Green one and black one. Are they positive? Yes. Why? Because anything toward the center, is positive. Therefore, I am going to have Fn sine theta plus Fs cosine theta equal mvt squared divided by what? R. Okay, this is from the first one. This is from number one. Let's say this is number one. So by the one, I got this. Number two, I don't have any force. It doesn't help me. On number two, I will say no help. Why? Because no force on tangent axis. Of course, we do have friction, but we assume that friction is not in the game because the friction force toward aft of the curve is important for us. That's the cause to slide out far from the curve. And also what? Yes, AT is 0. So this doesn't help me. But what about number 3? Let's say this is number 3. How many forces do we see on z-axis? Green one, Fn cosine theta, so anything up is positive. Anything down is negative, minus m, oops, sorry. Let me write that one first, minus Fs sine theta. This is friction force. Come on. Minus Fs sine theta, correct? Minus mg equals 0, which I can write equal what? So I can actually, just for saving time, I can write this minus mg equals 0, correct? Then move this mg over. It is negative, will be positive. So just for saving the time. Okay, so far good. So what I have, look guys, what I do have this. Fn sine theta plus, what is Fs? We know it's mu SFN. It's mu SFN. So instead of Fs, I'm going to put mu SFN. So plus mu SFN, this is times cosine theta equal mv squared. So this is tangent velocity divided by radius of the curve. In the same way, from number 3, I can get Fn cosine theta minus, what is Fs, guys? Mu is Fn sine theta equal equal just mg. So far good? Yeah. Let's do something. So I can say I can factor with Fn. And here I am going to have sine theta plus mu s cosine theta. This is ugly mu. Let me write it much better. Plus mu s sine theta, cosine theta, sorry, equal mv square. Of course, it's tangent divided by radius. And from this one, I'm going to factor with Fn. Cosine theta minus mu s sine theta equal mg. Do you see this? So I got two equations. Now what do you think? What can I do? Can I cancel Fn? Can I cancel Fn? Yes. So what I need to do, excuse me, I need to, so this is equation A, for example. This is equation B. I will say now I'm going to do A divided by B. Equation A divided by B. I'm going to get Fn sine theta plus mu s cosine theta divided by Fn cosine theta minus mu s what? Sine theta equal mv square divided by r divided by mg. Okay. Oh my goodness, why this becomes like that? Okay. Then if I keep going, watch guys, this Fn with this Fn what? They cancel each other. When they cancel each other, I am going to have sine theta I am going to have sine theta plus mu s cosine theta divided by cosine theta minus mu s sine theta. Oops. This is equal with m also cancelled, v square, which is tangent velocity divided by what? Rg. Let me go with big R. Now I want you to pay attention on this very important equation. So engineers, when they are going to actually make the curve on the road, in the highways, everywhere, they use this equation. Did you know that? What is Vt? It's speed of the car. Which is tangent velocity. What is theta? It's angle of banked curve. That means is by what angle your curve is tilted. So I want you from today, when you drive your car, when you go out, when you are starting to go inside the curve, to take the curve actually by your car, first look at the curve. If you are going to take your car toward the left, your tilt angle also must be toward the left. It has to be in the same direction as you are turning your car. If it is in opposite direction, your car will slide out. Your car will slide out. So theta is angle of banked curve road. What is mu s? It's static friction coefficient. It's a static friction coefficient, which between tires and asphalt or concrete. So, but remember, when it is foggy day, when it is icy day, when it is rainy day, when you have water on the curve, which that is the most critical section, conditions of the road, mu s is the minimum. Mu s is the minimum. So you have to be careful. What is r? It's the radius of curve. There you go. So this is a very important equation, guys. Very important equations. Now what I am going to do, pay attention. I want at this time to go over some conditions, to go over some ifs. And I want to say, what if we don't have friction? What if friction, it's impossible, but let's assume it's icy day. In icy day, like your curve is completely covered by ice, we can say friction is minimum. So, okay, friction is minimum. What does that mean? That mean is, come on. What if Fs becomes 0? Okay, if Fs becomes 0, therefore, we can say it's mu s. We don't have mu s, correct? It's 0. So if I substitute instead of mu s in this equation, do you know what I am going to get? I am going to get sine theta plus mu s is 0, so 0. Cosine theta is cosine theta. Mu s is 0. This is general equation. This is very important formula. Then this is equal with what? Am I right? So here, what I am going to have actually very important equation, tangent theta, which it comes from this. So I'm not going to say this is most important. No, this is the reality. This is the real world, because I cannot say friction is 0. Of course, friction is not 0, but let's do investigation about critical condition. What if no friction? Like, what if you go on what is that? Air track, frictionless air track, which it was in lab number 2. So tangent theta becomes what? Vt squared divided by Rg. If you find theta will be tangent inverse what? V squared divided by Rg. Do you know what is this theta? I will say this. This is theta is, it is the minimum angle, pay attention, that curve must be banked to prevent your car from what? From sliding out. If you go maximum by VT, tangent velocity. So what is VT? VT, it is, pay attention, maximum speed that your car can have it. That's the maximum. If not, your car will slide out. And we all will be in hospital if we go with higher speed as sign says on the curve. So here, pay attention. And on this one too. Watch. Oops. This should be this. What's wrong with this? Why it doesn't make lines sometime? Okay, VT, velocity, that is the maximum. So guys, when it says go with 45, that's the maximum speed that you can go. If you go with 46 miles per hour, your car will slide out. I'm sorry for you. I'm sorry for myself. If I go with higher speed than what the sign says, look at here. What is theta? It's the minimum angle that curve must be banked. For example, if your curve is like 15 degrees, for example, you are allowed only to go, for example, we can find it by, let's say, by 40 miles per hour. If you go by 41 miles per hour, your car will slide out. If you are allowed to go with 40 miles per hour, but curve, if it makes by 14 degree, your car will slide out. So make your banked curve angle more and more, then you are more in safe. Does make sense? So higher angle, more safety than lower angle, of course. But you know, making curve roads with higher angles, it's not easy. You need, the state, the engineers, the county, I don't know, the country, they have to spend more money because it's not easy to make banked curve roads. So that's why they make it like to have appropriated speed. You cannot have any speed that you want on the curves. Be careful about that, okay, guys? Now, I am going to talk about the second if. So this is if number one. If number one. What about if number two, guys? I'm going to talk about if number two. What is if number two? So here we had if we have no friction, correct? Now I am going to say what if theta becomes 0? Do you know what is theta is 0 means? Theta is 0 means your curve is flat. Your curve is what? this is theta means 0. So that means is your curve is flat and your car, let's say, which it goes on VT, it's just flat. Your surface, sorry, your surface is flat. This curve is flat curve. Okay, so that means theta is 0. So in this equation, is in the main equation, here instead of theta, I'm going to put 0. Therefore, I am going to have sine 0 plus mu s cosine 0 degrees divided by what? Cosine 0 cosine 0 minus mu s sine 0 equal v square over what? Rg, or big R, let me put. This is Vt. So sine 0 is 0, cosine 0 is 1, sine 0 is 0, cosine 0 is 1. So this section will be mu s. So sine 0 is 0, cosine 0 is 1, sine 0 is 0, and cosine 0 is 1. So therefore mu s becomes what? V square over Rg. Look at this. Here is if we have flat curve. So what is this? Mu s is, what is mu s? I will say it is minimum friction coefficient. It is minimum friction coefficient that that road at this time must have to prevent car from sliding out. When it goes maximum by Vt. And what is Vt? It's maximum velocity or maximum speed that car can have to not sliding out, out. If friction coefficient is mu s. These concepts are very important, guys. I want you to please pay attention, redo them. You have to know how we derive these equations, the Bankert curve road. You have to know how do we derive this equation. Very important, okay? If you have any questions, let me know. Now, I am going to do one problems for you. Question says this, for example, example says, how much must be maximum, how much must be maximum speed of a car how much must be maximum speed of a car if it goes from a curved road with tilt angle of 15 degrees on a rainy day with mu s. On rainy day it's very small. Let's say mu s is it's 0.8 almost. Let's say 0.1 is okay. 0.08. How much must be maximum speed of a car if it goes from a curved road with tilt angle of 15 degrees on a rainy day with mu s is 0.08. Then right here that radius of curve road is what? Is let's say 100 meters. Find your answer by miles per hour also. Okay. Yeah, when I make my laptop actually flat and put it on my table, it's easy to write it, but when it is with the angle, it's hard. In that time you can't see me, but we will make it, no worry. Okay, so how much must be maximum speed? So they want me to find what is Vt if it goes from a curved road with tilt angle, so theta is 15 degrees, mu s is 0.08, curved road is 100 meters. Okay, so what is my formula? Sine theta, correct? Sine theta plus mu s cosine theta, correct? Divided by cosine theta minus mu s sine theta equal v squared over rg. So here is your equation. Look guys, sine theta plus mu s cosine theta divided by cosine theta minus mu s sine theta equal v squared divided by rg. Okay, so this vt, its tangent velocity, same thing. Now let's substitute. Sine theta is sine 15 degrees, mu s is 0.08, cosine theta is cosine 15 degrees, correct? Divided by cosine 15 degrees minus what is mu s? 0.08 cosine, excuse me, sorry, sine 15 equal v squared divided by what? Rg. R is 100 and G is 9.8. Therefore, let's substitute, let's find the answer. 0.08 times cosine of 15 plus sine of 15. Remember, your calculators must be by degrees. Divided that number divided by cosine of 15 minus minus 0.08 cosine, sorry, sine of 15. So I got 0.355 equal Vt squared divided by 980. Now Vt will be that number times 980, then take square root of that number. So I got like 18.66 meters per second, correct? This is my answer. Now 18.66 meters per second, I want to convert it to miles. So this will be miles, this will be meters, then hour, then second here, correct? So I know 1 mile is 1609 meters, and 1 hour is 3600 seconds. So if I do that number times 3600 divided by 1609, there you go. So it comes 41.7, let's say 41.8 miles per hour. This is my maximum velocity that I can have it on the rainy day if I go from this curve. Pay attention. If my radius is 90 meters, this, you tell me, velocity must be less or more than this. If my radius becomes smaller, I need to go slower. It has to be smaller than this. More radius, it's more safer. So the curves that they are more open, of course, it's easy to take them than the curve that they are very curved. Make sense? So you have some questions in your homework, chapter 8. I will do more problems for you on this week during lab times, and I will post them for you. Okay? So study, understand this lecture. It is very important lecture. All right. Now, I want to do one question for you. Okay? Let's see what it says. So this is like example. Question says below figure find an expression and value of friction force between car's tire and road on each section of the road. Mass of the car is 1500 kilogram and kinetic friction coefficient is 0.3 and radius of the curve of the road, let's say, is 90, let's say 110 meters. Okay, I have to move this laptop very slowly. Okay, so pay attention on this problem. Okay, watch, guys. Let's say we have, let me do like this. Okay, all right, so we have like a car here and also here, so it is same car, and also it goes to the bottom of hill. So this is car which it goes by constant velocity. Okay, car, that's right, has constant velocity of 50 miles per hour. Okay, now, so this road, let's say if you go to, you know, after the city, especially if you go to Sonora area or Yosemite areas, you will see a lot of roads. They are all up of hill, then they go to the down of the hill, so, and then they are becomes flat. So many different shape we have for the roads. So question is, find value for friction force. And the kinetic friction coefficient is 0.3. Look, guys, so your car actually goes by tangent velocity, which it is all constant. Okay, so first of all, I have to find that 50 miles per hour. 50 miles per hour, if I convert it to meters per second, I'm going to multiply that by 1609 divided by 3600. So my answer will be by meters per second. That's my first job. 50 times 1609 divided by 3600. The answer is 22.34 meters per second. So 22.34 meters per second. This is my tangent speed, tangent velocity that car goes actually with constant value everywhere. Then it says mass of the car is 1500 kilogram. Then also you have kinetic friction, mu k is 0.3. Radius of the road is 110 meters. Okay, and speed is that. All right. Find an expression and value of friction force. Very good. We know what is friction force equation, or FF. Is it not mu Fn? Yes, it is. This is Oops, sorry. This is Fn. Sorry, friction force, mu Fn. Now we have to work on Fn, correct? So we have three sections in this problem. One section is this section, which the car is in the top of the hill. One section is the flat section. One section is the car is in the bottom of the hill. Okay, so I'm going to go, I will say, okay, this is part one. This one is part two, flat section. And this section is what? Part three. Okay, pay attention. Let's verify very quickly your coordinate system. Look, here is the center of the section. So my radial axis, this is my radial axis. It's toward the center. Why? Because in reality, your circle is like this, correct? So your center is here. So that's your radial axis. Tangent axis, it's tangent on the circle. So this is my tangent axis. What about Z? If you do this, look guys, this is tangent axis, your index finger. Your middle finger is R toward the center. And this is your thumb finger goes inside the board. It's Z axis. So Z is inside the board. Z is inside the board. And I don't have any forces on that direction. So what I see here, I see sigma F on. So let me do for part one. So for part one, okay. I see that I have only forces on radial axis. Let's verify forces on radial axis. Watch it. How many forces do I have on radial axis? Let me go by green. Of course, this is mg. And what is this one? Fn, correct? mg and Fn. Therefore, I don't have forces on tangent axis because Vt is constant. This Vt is constant, so no acceleration. And I don't have friction. I do have friction. Yeah, I do have friction. And I don't have forces on z-axis, I mean. Okay? So how many forces do I have on radial axis? mg and Fn. Any force toward the center is positive, after the center is negative. So I am going to have mg minus Fn is equal what? mv squared over r. So far makes sense? Then here Fn becomes m, we can factor with m, g plus v squared over r. Now, if I want to find what is friction force equation for that section will be mu Fn. Mu instead of m, I'm going to write mg plus mv squared over r. This is for part one. I did mistake, right? mg minus, sorry, this will be minus. I do have office hour at 3:30. That's why I can't focusing a little bit at this time. So this will be mg. Fn is mg minus that, correct? There you go. Now we can find the value. So this is expression actually. So if I find the value, mu is 0.3, m is 1500 times 9.8, correct? Minus 1500, velocity is 22.34 to the power of 2 divided by radius is how much? 110. So find this value. So now this is your job that you have to calculate it. Let's go on part 2. Let's verify forces. So part 2, what I have x and y. So I can say here I have only mg and also I have Fn. Therefore, what is friction force equation? It's mu Fn. So I have to see what is Fn, correct? So I see that they are on y-axis. So sigma F on y-axis is 0. So I am going to have Fn is equal with mg. Then friction force is equal with mu mg. So this is my expression for friction force. Now if I substitute, it will be 0.3 times 1500 times 9.8. That will be the answer. And for part 3, let me go here. Your center is here, guys. What I do have Fn, correct? And I do have mg. So for part 3, pay attention here. I have total forces on r-axis because here is radial axis. It's toward the center. How many forces do I have on radial axis? Fn and mg. Which one is positive? Fn. Why? Because Fn is toward the center. So I'm going to have Fn minus mg equal mv squared over r. So guys, this is different with part 1. So Fn becomes mg plus mv squared over r. So I can write Fn is, so this is apparent weight, mg plus v squared over r. So very similar to find apparent weight of person inside elevator if elevator goes up or down. So this is very similar to that problem. Therefore, friction force becomes mu times mg plus mv squared over r. This is expression of part 3. Now if we substitute, Ff becomes mu is 0.3, m is 1500, g is 9.8 plus 1500 times, what is the speed? 22.34 to the power of 2 divided by 110. So we can find ff3 here, correct? Then here is ff2. Then also here we can find what? ff1. Let me see. I do have 3 minutes. Mu is 0.3, mass is 1500, g is 9.8, So this will be 4410 newtons. Okay, yes. If I do that number minus 1500 times 22.34 square divided by radius 110, okay, 1500 times 9.8, so here becomes times 0.3, 2368 newtons, and here will be 4410 plus 6451 newtons. So I want you to redo these sections, then check the answers, please. So work on this problem, and this is very similar to this problem. Question says, below figure, find apparent weight of a 80 kilogram person inside cabin of a Ferris wheel. Ferris wheel rotates with 8 RPM and its radius is actually 10 meters. Part A, it says at lowest section of wheel. Part B says what? At the highest section of wheel. Okay, so one time here. So imagine this is person, it is here. That's part A, and one time he is here. Okay, so this will be part B. I want you to do this problem, work on it, and send me the answers, please. Okay, email me if you have any questions. Have a good day. Be safe, be healthy. I love you guys. Bye.